This worksheet here that I gave you Monday. Okay. Does anybody know what the grade of a road is? Say again. Not quite. Anybody have any idea? Like if I say, anybody you've been to the mountains? Anybody been driving through the mountains? Okay. So you're driving through the mountains. You usually see these when you're going downhill. Got yellow signs. And there is gives you something like that. And there's a little car on it. And then it'll have like a 7%. And that's a warning. It's a yellow sign. It's a warning that the road is going to be a pretty steep road in regards to traveling in a car. Okay, have you ever done it? How many of you have your actual license and can drive? Okay. You ever drive through the mountains? Oh, it's terrifying sometimes. Because you come across, so you'll be driving and hit a curve, and then right away it says 7%. You're going almost straight down. And you take your foot off the accelerator, you can hit like 110, not doing anything, okay? So then you're in like 3 lanes of traffic and other people are doing the same thing. It's messy. But what it means is that you say steepness. When I'm talking about Algebra 1, what was a word that referred to the steepness of something? Slope, okay? So the grade of a road is just the slope of the road. Okay, but it's represented as a percent. Okay, so this is terminology that like civil engineers will use. Okay, people that work for ODOT, this is common knowledge for them. Hey, this road's 7% grade or something like that. Okay, they want to know what is the angle that the road makes if that's the case. Okay, well, how do I get percentages? What do you divide by to get a percentage? 100, right? So what they say, and this is either decreasing or increasing, it doesn't really matter, it's the same. They're asking if this is my road, and we just said that the steepness is the rise over run, correct? It's the slope. So here's my rise of the road, and here's my run. Okay? If I'm doing slope, so slope, which we said is the grade of the road, which is rise over run, which is written as a percent for the grade, right? Which one of these numbers would be best to be 100, the rise or the run? The run. Let's let the run be 100. Whatever. Could be feet, could be miles, could be meters, whatever. Okay? So that would be 100. If the rise over run is going to be 7%, what does the rise have to be in this case? 7. And the way we get that is we simply take the run and multiply it by 0.07, and it gives me that. Does that make sense, everybody? So when they say 7%, what this means, let's say we're in feet here, it means if you travel 100 feet horizontally, in that direction, on this road, your horizontal displacement is what we call it, of 100 feet will yield you a gain of 7 feet vertically. Okay? Is there a run on a treadmill? And some of those treadmills, they have the incline on them, right? And it'll have a 1, a 2, a 3, or 4. Let's say that we put our treadmill on the 7. It's a 7% increase. Okay, what that means to us is if I'm going to, let's say, run 1 mile, okay, as the treadmill is displaying information to me, it shows me running that lap 4 times, right? And I will run 1 horizontal mile. But then at the same time, because I was on 7%, it will show me the actual gain that I made in elevation, right? Does that make sense to everybody? So this idea is being realized on treadmills as well. Now, those 1, 2, 3, 4, 5, 6, 7, I don't know if those are really percentages. A 7 might actually only be like 3.5%. I don't know. Does that make sense? I don't know the formula that they use to attach to the 1, to the 2, to the, I don't know if it's a direct percent. But that's the idea, okay, is that when you are running horizontally at an incline, you're gaining vertical distance as well. So now they want this angle. They're wanting the angle that the road is making with the horizontal. Okay, so how do I find that angle? Tangent. This side here is opposite, right? This side here is adjacent. So I'm going to say a tangent of that red angle, I'll just call the red angle x, is equal to 7 over 100. So if I'm going to try to find x, I'm trying to find the angle, you use the tangent inverse, right? So I'll tangent inverse both sides. It leaves me just x on the left and leave me tangent 7 100ths on the right. So let's see when we take our calculator what that gives us. Internet's blazing today. Just use this calculator. And I froze it. All right, great. I'll use this one. Maybe. So if we take tangent inverse of 7 over 100, okay, now I get that number, and I look at that number, and I'm starting to think that's kind of a weird angle measurement, right? It's not very large, okay? I know that tells me that I'm in radians, and I need to be in degrees. Even though that's not entirely large either, that is something to always think about. What mode is your calculator in? Okay, and I know Desmo starts off in radians. So 4 degrees is that angle right there that we're recognizing. Okay. Now we had to introduce some numbers here, right? We had to introduce this 100 and this 7. Okay, because of that 7%. But it could have been, let's say, that I look at just like, let's go 40 feet. Okay. If I only travel 40 feet horizontally, then for the same reason as before, I'm only going to raise or rise 7% of that 40. Does that make sense? Okay. So, anybody know off the top of the head, if I take 40 times 0.07, what's that going to give me? What's 4 times 7? 28. So 40 times 7 would be 280, right? Does that give me 2 decimal places? So it'd be 2.8, right? Does that make sense? So if I would have used 40 feet instead of the 100, okay, I would have needed to compare that to, so I go tangent inverse of 2.8 divided by 40. Does it still give me the same angle? Okay. And the reason for that is these two triangles, this red one, that red triangle, and the black triangle, are they similar? By angle, right? Okay. And the similarity factor is built into this tangent. Okay. Anything that has a 4-degree angle, the opposite side divided by the adjacent side, is going to be that 0.07, okay? So that's something to think about as you do these problems. Some of these problems, and this is the reason I gave them to you, you can do them, but it doesn't give you all the numbers you need, right? You have to maybe understand some conceptual ideas like grade, like slope, and the idea that of similarity. It means I get to choose my numbers, okay? But once I choose maybe that distance there, it's going to dictate that distance, okay? So I can't just randomly choose both of them. Number 20, kind of the same idea. It says a road climbs at an 8-degree angle. Okay, so let's it's a terrible right triangle, but we're going to rise at an 8-degree angle, and they want us to come up with what the grade is, right? So the grade, remember, is the what? Grade is the slope, okay? So I need to figure out, if this is 8 degrees, I need to figure out that distance per that distance. Okay, obviously this is my road, right? This is my rise, and this is my run. Okay. Now the idea here is that we don't really care how long this road is. This road could be 1 mile, could be 2 miles, could be 100 miles, could be 50 feet, doesn't matter, okay? We got to figure out, of this road, one of these numbers, because we're ultimately going to choose what we want the other one to be, okay? So in doing this problem, I'm actually going to make 18 degrees instead of 8, because I don't want to give away the answer. But if that's 18 degrees, the rise or the grade of my road is 18 degrees, okay? Or not the grade, the angle of elevation or inclination here is 18 degrees. We want to find the slope. So let's again go, let's say we travel 100 feet that direction. With that information, if I'm traveling 100 feet, can I let that be x? And can I say, and actually I'm going to let it be y because it's vertical, doesn't matter. But can I say tangent of 18 is equal to y over 100? That makes sense? So now I have 100. Tangent of 18 is equal to y. We'll type that in my calculator. So 100 tangent 18 gives me that distance, okay? Now what is that distance? It's my rise, correct? So what would my rise divided by my run look like? Okay, so I'm just gonna call this R. Oh, that does something I don't want it to do. Let's call this S. If I go S, which is my rise, divided by my run, which was 100, does that give me my slope? Is that rise over run? Does that kind of make sense? Okay, so that's my slope. And as a percent, that's 32%, right? So with an 18-degree angle, we end up with a 32%. Now, the idea is it shouldn't really matter, guys, what we chose this 100 to be. Give me another number.
50.
Give me one that's not so comparable to 100.
25.
Okay, you said 51, you said 25. Let's go 51.25. Because it shouldn't matter, okay? If that's 51.25, okay, I'm going to say now tangent of 18 is equal to y over 51.25, right? If I type in, okay, cross multiply to get 51.25, tangent of 18 gives me that number right there, right? That's my rise, correct? Let's take that number, I'll call that E, and let's divide that, so that's my rise, let's divide that by my run, which you told me was 51.25. What, 51.18, is that right? 51.25, so rise run 100. Should give me the same 32. 100, 218. So we chose this to be 51.25, that's y. Tangent of 18 is y over 51.25, 51.25. Times that. So let's do this. There we go. I don't know what that was doing. That was weird. It might have been because I made it E. E is actually a number, like pi. I don't know if that has anything to do with it. But once I do that, so does that number right there end up being the same as that one? Now they're different, that last decimal, right? And the reason they're different, if you remember, I cut and pasted that top number. Okay? So there's a little bit of rounding there. But the idea is that it shouldn't matter what that 51.25 was. Okay? And it doesn't matter. I chose that to be my run because it makes the math a little bit easier. But let's say that you chose, if we're going 18 degrees, let's say you chose this number. Let's say the rise. Give me a number for rise. 33. Okay. Let's find the run. Okay. So I'd say tangent of 18 is equal to rise over run, right? If I cross multiply, have you guys recognized that when we do this cross multiplying, what happens ultimately with that and that when the variable's in the bottom? They just switch spots. So it gives me x equals 33 divided by, that'll always work. So that's kind of a quick rule that we use. But if I go 33 divided by tangent of 18, it gives me that number there, right? So that's my run. So let's take 33 divided by my run. So that's rise divided by run again. And we don't want to put dollar signs in there. Does that still give me the same 32.49 or 32% grade that the other ones were giving me? That makes sense? So if we understand that idea, when they talk about a grade of a road, we don't care what one of those distances is, okay? The nice thing, the easy thing to do is let one of them be 100. And I like the run to be 100, but it doesn't matter, okay? So in your homework, kind of keep that in mind. That is, I've seen in, of course, exams use the word grade on questions, okay? So I think it's important for us to be able to understand and interpret the grade of a road. Let's go to 22. What do you guys know about a rhombus? And this is what I was trying to focus on and remind us when we were in chapter 6 that our properties of parallelograms are going to come back, and they come back inside problems like this. This question says, 22, you have a rhombus that has a diagonal of 4 and a diagonal of 10. Find the angles of the rhombus. So our goal here is to find that angle and that angle, knowing that maybe that distance is 4 and that distance is 10. Okay? Now in doing that, we need to know a handful of properties. First thing, what do you know? Is there anything you know about a rhombus? Just tell me everything you know real quick. What's the definition of rhombus? All sides congruent. Okay, so we know that. What do you know about the diagonals? And the way I drew them might be eye-opening for the property that we're looking for. They're perpendicular. So there's your right triangles, right? So now that I got right triangles, I know this can come into play. Okay, it only works with right triangles. What is the other last thing you know That's not the last thing, a couple other things, but what is one of the main things that you know about the diagonals of a rhombus? They bisect each other, and that's the pivotal part of this question. If the red one is 4, what's that one? 2. If the purple one's 10, that one is 5. You have a right triangle now, and you've got ultimately 4 right triangles that are congruent here, but that green right triangle, do you have the ability to find that angle right there? I'm going to call that angle X real quick. I'm going to say a tangent of X is equal to opposite over adjacent, right? Okay. Last class, we had a discussion about when to round, because these questions all ask you to round, right? If I type in tangent inverse of 2/5, gives me that number there, and in degrees it's 21.8. Okay. Somebody in the last class said, oh, I'm going to round that to 22, which, okay, I get it. That's fine for this problem per what that 8 was. And they say, okay, well, if I round that to 22, then remember what they wanted. They wanted the angles of the rhombus. So what am I going to need to do with that 22 degrees to actually find that red angle? By 2. I need to double that, okay? So if I round here and then I double it, I get 44, right? And then the other angle, you guys remember the relationship between that red angle and that red angle? They have to 180. So I could take 180 minus 44, right? Get 136. So that would be maybe those two angles. And that's okay right now that I've got that because of how this 8 showed up. What I think is more appropriate is to not round this number. And I'll show you why here in a moment. If I don't round that, I can double it, right? And now I get 43.6. And the idea, because that's a 0.6, that if I would have rounded before and rounded to 22 and then doubled it, does this still round to 44? Okay. So, but now if I take 180 and I subtract that number, does that still maybe round to 136? So no concerns there, right, with that? Well, let's say we had something like this, and I might have to mess around a little bit to get this to demonstrate the way I want it to. Let's say that this number here was 2 let's go 1.999, nope, 1.8. Well, let's just do it this way. So I'll leave the 2/5 there. But let's say for some reason, whatever these numbers were, that 21 actually turned into 21.4. Okay? And you doubled that right away. Does that make sense? Or you round that right away. What would you round 21.4 to? If we're going whole numbers. 21. And if you double that, you get 42. Okay? So we'd say one of our angles would be 42. But if I take 21.4 and double it first, what would you round that number to? 43. Do you see how when I cut that 0.4 off right here and make it 21, that error is compounded by that 2 that I multiply by? And now, if I would have rounded early, I get 42. But the later I round, I get 43. If I'm on the end of course exam and they round, and this is the way they structure it, they're always going to round as late as possible. But you round an early intermediate value pretty bad, you could have gotten 42 for an answer, but in the background, they've got 43 stored. And you'd be wrong. Does that make sense? And it might be, they maybe go to the 10th place and you have 42.1, but they have 42.2. You'd be wrong. Does that make sense? And that I don't like the test for that reason. Okay, I think the test does make you think, which is a good thing. It's more difficult than maybe other tests you've taken, but it's a lot like Math Excel where you've got to type in answers and match up to the answers that they got in the background. It's not multiple choice, okay? The ACT, obviously, you go through the ACT, you got 42. The only option that makes sense to you would be 43. Does that make sense? And you can circle C or whatever. But on that end of course exam, your rounding could be a problem. So rule of thumb is round as late as possible, okay? I'm gonna try to show you techniques, and we'll see this here in another example of how you can use your calculator to essentially not round at all for us, okay? So that's how we're gonna do 22. 23 is similar, so I'll let you still deal with the rhombus. Let's jump down to 27 real quick. Yes? 24? Yes, if we've got, so a rectangle, 80 by 20. Let's, I'm gonna change the number. So let's go, it's a rectangle that is, let's go 60 by, I don't know, 110. Doesn't really matter. When they ask you, so the wording on that question is find the angle, the measure of the angle that is acute when the diagonals intersect, right? So what they're asking you to find is to look at either that angle there or that red one. And we're gonna work with both of them and figure out which one's acute. The blue one by picture looks acute, right? Okay. But one of those is gonna be acute, one of those is gonna be obtuse. Okay. In order to do that, we need to construct a right triangle. Okay. Do we remember what the diagonals of a rectangle are to one another? There's two relationships that diagonals have with one another. What do they look like in terms of their length? They're congruent, okay? The other thing, because they're a parallelogram, they bisect each other. So what happens is that that distance there and that distance there are the same. And all of these are really the same, but I'm only gonna look at those two. And you can do this problem looking either at that triangle, I'm gonna look at this obtuse triangle here, or you can look at maybe one of these what look to be acute triangles. Does that make sense? You can either look at triangle number 1 or triangle number 2, doesn't matter, okay? I like looking at triangle number 2. Now that's an isosceles triangle, right? So this is going to piggyback off of something that you probably had to use in question 21, okay? Where if I've got an isosceles triangle, does this line right here exist? And it exists in a fashion that it could be perpendicular down here, right? And if it's perpendicular, what does it do to that 110? Splits it in half. So that would be 55, right? Just some features about a rhombus, and it's because of congruent triangles and all that kind of thing. What do you think that distance right there is going to be? 30. Okay. Now, does that allow you to maybe find this green angle? That make sense, everybody? Yeah.
Where did you get 30?
Because this is 60, right? And the center of your rectangle is going to be halfway in between both lengths and widths. I'm going to introduce a label or a symbol here. Does anybody know what that symbol is? It's a circle with a slash through. It's a Greek letter. Anybody in science use that yet? Your end of course exam might use this. That's the letter theta in the Greek alphabet. Usually we use that letter to represent angles in trigonometry, okay? Instead of using like X or Y or whatever. So we use theta. Just a notation thing. 55 would be opposite theta, right? 30 would be adjacent, correct? Which trig ratio do you use for that? Tangent. So I'm going to say tangent of theta is equal to 55 over 30. Then theta will equal the tangent inverse of that, right? So that's only going to give, so just think about this, and there, like I said, there's other ways of doing this problem, maybe more direct ways, and getting my answer here in a moment. But if I have tangent inverse of, what would we say, 55 over 30, it's giving me 61 degrees, correct? Okay, so this angle here is 61 degrees. That doesn't tell me anything about this acute angle that I'm looking for, right? What would this blue angle be in comparison to that 61? How much bigger is that blue one? Double. So if I take 2 times that, that gives me that blue angle, right? How does that blue angle and the red angle that I'm actually looking for, how are they relating to one another? Say again? Not the same. They're supplementary. So if I take 180 minus that blue one, it should give me that angle to be 57. Okay. There at the end, there, and I went that route because some people are going to draw their picture not thinking that there's alternative routes, and that might be the first thing they come up with. So I want to give them an option of how you could find that red angle using that structure. Let's do it a different way. If I look at this triangle, does that distance exist? That dotted distance. What do you think that distance is going to be? 55. That's still going to be a right angle, right? What is this distance right here going to be? 30. I can still call this, I'm going to call this theta. Can I say tangent of theta is now equal to 30 over 55? The math is a little bit different than what we did in purple, right? If I go tangent inverse of 30 divided by 55, it gives me, again, this theta, right? How do I get that entire acute angle then, if that's theta? What is this dotted line? What's that due to that vertex angle of the isosceles, that altitude due to that isosceles triangle's vertex? Splits it in half. So what am I going to have to do with that 28 number? Multiply by 2. Does that number end up being the same as that one? Just 2 different approaches, right? Depending on which triangle you look at. I didn't have to do any supplementary angle work using this triangle here on the left. Okay. I don't know if I mentioned this to you guys. Arctangent and tangent inverse written this way. Do those generate the same number? So arctan and tangent inverse, they are the same thing, okay? This is more of an old world, before like technology started to be a very prevalent thing in the classroom, before like typeset and textbooks and that type of thing. This was what we used in contrast to this, okay? But they are the same. I like using this one on Desmos because it's easier to type in than getting that superscript. So I just want to make sure nobody gets confused over that. Does that help, Emma? Good. What about jumping down to, I just want to make sure we look at this prism question. There's two of them here. And discuss, if you were to look at this angle right here, if you were to take a protractor and go up to my whiteboard and lay the protractor on that thing, is it going to be 90 degrees? No. Okay? Think about this angle here, and maybe this makes more sense looking at that angle. We should know in a prism, if I've got a prism here, right? That angle right there that I just highlighted in red at A, that's 90 degrees, yes? Okay? If I put my protractor on the whiteboard up here, that angle is going to be recorded as an acute angle per that protractor, right? So drawing three-dimensional shapes on two-dimensional surfaces creates a perspective kind of issue, okay? We know it should be 90 degrees in real life, but if I put a protractor on it, it's not 90 degrees. But we have to assume that we're in kind of real life. We can manipulate. We have this in our hands. We can manipulate it. So we're going to make this something that is 90 degrees there, okay? What should this red angle right here be? 90 degrees. So what we'd be looking at here, guys, is if I took this prism, I don't have any markers up here, and I go from that edge, okay, and then follow straight across that diagonal there, okay? Well, that edge and this plane here that my hand are on, they're perpendicular, right? So there should be a right angle right here where my cursor is. I think that's easiest to see maybe here, okay? Over here on the left-hand side, I've got kind of the bird's eye view. If I'm looking straight down on the shape, this would be the image that I see, right? This would be the three-dimensional shape in my hand, okay? They're telling me that it's 3 by 4 by 2. We're looking at that shape right there, okay? And they want to know what is the measurement of the, and we're looking at the red triangle, of that angle where my cursor is in the red triangle, okay? So if you're looking at that red triangle kind of head on, we're looking at that angle right there, okay? Well, throughout the problem, I don't know anything about that right triangle yet, except for they tell me the altitude is 2, I believe. So they tell us that this distance, F, to whatever letter that is, that's 2, correct? Okay. We don't know that dotted distance right there. Good talk. What is over here? This would be 3, right? This was 4, correct? Okay. You see that this right triangle right there, or the other one, is that right triangle right there? You can't maybe see that. It's that triangle there.
Pardon the interruption for a couple of afternoon announcements. All track athletes are to change for practice at the Red Barn and then wait to enter until the coaching staff is present. Also, all cheerleaders can please pick up their wall signs in the athletic office. Thank you.
All right. So do you see how that 3 and that 4 can transfer over here to the actual three-dimensional shape? If I'm looking at 3 and 4 as the side lengths of that triangle, how do I find that distance? A squared plus B squared equals C squared, so you're going to give me that to be 5. If that's 5, that can transfer here now, right? So now in that red triangle, this angle right there that we're trying to find, I'm just going to call it theta. That distance there is going to be there. And that 5 we just found would be that. And now we can find out what that angle is in that red triangle. Okay. We are going to tomorrow work a little bit more. I want to show, last class we got through And I guess that announcement got me off track, but we got a little bit of time. So I do want to go through, at least start you off on this last question. This is more of, I'm not saying you won't see this on the end of course exam. This is kind of like an ACT question, okay? Asking you to find the height of this second building. If we read through this, just to save time, I'll save you from reading it. But we're looking for that blue distance right there. Does that make sense? If you can see that blue distance, I apologize for my coloring. That distance there, okay? We know part of it. We know through the description that they tell us this distance here is the same as that distance there. Does that make sense? So we know B to H is 40 feet, okay? That's a right triangle, correct? And that is a right triangle. But which one of those triangles do you know more information about? The smaller one. You know in that green one, you've got 37 and you've got 40 here, right? Do you have the ability to find that distance there, x? Using which trig ratio? Tangent 37 is 40 over x, right? Opposite over adjacent. So x is going to be 40 divided by tangent 37. Okay? That is that distance right there. And you can type that in your calculator. I think it's you like 50, 53-ish. Okay? So now if I look at the blue triangle, you know this distance to be 53, right? Can you find that distance y if that angle there is 61? Okay? Which trig ratio are you going to use there? Tangent again. Tangent of 61 is equal to y over that 53 number, right? So 53 tangent of 61 is going to give me y. Okay? That's y. And that is only, per my picture, per how I described this, that is only going to be that distance right there. Does that make sense? So what would I need to do with that distance to actually get the entire height of the building? Add 40. Now, when we do this, and you gave me 53, which is great, I want to avoid rounding. So I think this is a way, I want you guys to get used to using Desmos. It's what's going to be on the end of course exam. Going through, we said that the first one was 40 divided by tangent of 37, right? That was that first distance. Now, I look at that and I got a negative number back, right? Can distances be negative? If that ever happens to you, that's an indicator that your calculator is in the wrong mode. There's the 53 that Landon gave me, right? Okay. I'm going to let that be, I'm going to just label it as like L, okay? The other number that we came up with was 53 times tangent of 61, right? Well, now I'm going to go use L times tangent of 61. Does that make sense? So when it sees the L, it's actually cutting and pasting that number and multiplying by tangent 61. I'm going to then add 40 to that, and it gives me my angle or my distance of that building of 135.76. Okay? We're running out of time, but last class we went through this rounding that 53, and we found out there was like it was greater than 0.1% error. You guys do percent error in your labs in science, right? Okay. So that is the exact answer right there. If we use 53 tangent of 61, get 96 and add 40 to it, we get 136. Okay, so I'm going to take, I'm just kind of, in science you go like 136 minus, so it's your experienced value minus the actual value, divided then by the actual, and then multiply that by 100. And in this case, it's almost a 0.2% error. Does that make sense? where that could be a large enough error to create some issues. Now, if I'm just trying to find the height of a building, not a big deal. If I'm trying to land a rover on Mars or something like that, or if I'm SpaceX and I'm trying to land a rocket on a ship in the middle of the ocean, that rounding error there is going to be very important. Does that make sense? So context of the problem might dictate how and when to round. But just a rule of thumb for the things that we do, we're going to try to do it as late as possible, okay? We're going to round later in the problem. That's gonna mitigate a lot of that error. Keep working on that. I'm gonna open up a math Excel here in a little bit that's got some of those questions on it, and that's gonna be due tomorrow evening, okay? I'm also gonna move 8.4 back to tomorrow evening if you didn't get that finished yesterday. Okay? We can talk about some questions out of 8.4 tomorrow if we need to. Yes?
Does that worksheet need in writing still?
No, I'm gonna move it to tomorrow. So it'll show up on Math Excel as worksheet like 8.2 or something like that. I guess 8.3.